A capacitor is a passive two-terminal electrical component used to store electrical energy temporarily in an electric field. The forms of practical capacitors vary widely, but all contain at least two electrical conductors separated by a dielectric. The conductors can be thin films, foils or sintered beads of metal or conductive electrolyte, etc. The non-conducting dielectric acts to increase the capacitor's charge capacity. A dielectric can be glass, ceramic, plastic film, air, vacuum, paper, mica, oxide layer, etc. Capacitors are widely used as parts of electrical circuits in many common electrical devices. Unlike a resistor, an ideal capacitor does not dissipate energy. Instead, a capacitor stores energy in the form of an electrostatic field between its plates. When there is a potential difference across the conductors, an electric field develops across the dielectric, causing positive charge plus Q to collect on one plate and negative charge minus Q to collect on the other plate. If a battery has been attached to a capacitor for a sufficient amount of time, no current can flow through the capacitor. However, if a time-varying voltage is applied across the leads of the capacitor, a displacement current can flow. An ideal capacitor is characterized by a single constant value, its capacitance. Capacitance is defined as the ratio of the electric charge Q on each conductor to the potential difference V between them. The SI unit of capacitance is the farad, which is equal to 1 coulomb per volt. Typical capacitance values range from about 1 picofarad to about 1 millifarad. The larger the surface area of the plates, and the narrower the gap between them, the greater the capacitance is. In practice, the dielectric between the plates passes a small amount of leakage current and also has an electric field strength limit, known as the breakdown voltage. The conductors and leads introduce an undesired inductance and resistance. Capacitors are widely used in electronic circuits for blocking direct current while allowing alternating current to pass. In analog filter networks, they smooth the output of power supplies. In resonance circuits, they tune radios to particular frequencies. In electric power transmission systems, they stabilize voltage and power flow. History. In October 1745, Abel Georg von Kleist of Pomerania, Germany, found that charge could be stored by connecting a high-voltage electrostatic generator by a wire to a volume of water in a handheld glass jar. Von Kleist's hand and the water acted as conductors, and the jar as a dielectric. Von Kleist found that touching the wire resulted in a powerful spark, much more painful than that obtained from an electrostatic machine. The following year, the Dutch physicist Peter van Musschenbroek invented a similar capacitor, which was named the Leyden jar, after the University of Leiden where he worked. He also was impressed by the power of the shock he received, writing, "I would not take a second shock for the Kingdom of France." Daniel Growlithe was the first to combine several jars in parallel into a battery to increase the charge storage capacity. Benjamin Franklin investigated the Leyden jar and came to the conclusion that the charge was stored on the glass, not in the water as others had assumed. He also adopted the term battery, subsequently applied to clusters of electrochemical cells. Leyden jars were later made by coating the inside and outside of jars with metal foil, leaving a space at the mouth to prevent arcing between the foils. The earliest unit of capacitance was the jar, equivalent to about 1.11 nanofarads. Leyden jars or more powerful devices employing flat glass plates alternating with foil conductors were used exclusively up until about 1900, when the invention of wireless created a demand for standard capacitors, and the steady move to higher frequencies required capacitors with lower inductance. More compact instruction methods began to be used, such as a flexible dielectric sheet sandwiched between sheets of metal foil, rolled or folded into a small package. Early capacitors were also known as condensers, a term that is still occasionally used today, particularly in high-power applications, like automotive systems. The term was first used for this purpose by Alessandro Volta in 1782, with reference to the device's ability to store a higher density of electric charge than a normal isolated conductor. Since the beginning of the study of electricity, non-conductive materials like glass, porcelain, paper, and mica have been used as insulators. These materials some decades later were also well suited for further use as the dielectric for the first capacitors. Paper capacitors made by sandwiching a strip of impregnated paper between strips of metal, and rolling the result into a cylinder were commonly used in the late 19th century. Their manufacture started in 1876. And they were used from the early 20th century as decoupling capacitors in telecommunications. Porcelain was the precursor in case of all capacitors, now belonging to the family of ceramic capacitors. Even in the early years of Marconi/S wireless transmitting apparatus, porcelain capacitors were used for high voltage and high frequency application. In the transmitters, on receiver side, the smaller mica capacitors were used for resonance circuits. Mica dielectric capacitors were invented in 1909 by William Dubilier. Prior to World War II, mica was the most common dielectric for capacitors in the United States. See ceramic capacitor #history. Charles Pollock, the inventor of aluminum electrolytic capacitors, found out that the oxide layer on an aluminum anode remained stable in a neutral or alkaline electrolyte, even when the power was switched off. In 1896 he filed a patent for an electric liquid capacitor with aluminum electrodes based on his idea of using the oxide layer in a polarized capacitor in combination with a neutral or slightly alkaline electrolyte. See electrolytic capacitor #history. With the development of plastic materials by organic chemists during the Second World War, the capacitor industry began to replace paper with thinner polymer films. One very early development in film capacitors was described in British Patent 587953 in 1944. See film capacitor #history. Solid electrolyte tantalum capacitors were invented by Bell Laboratories in the early 1950s as a miniaturized and more reliable low-voltage support capacitor to complement their newly invented transistor. See tantalum capacitor #history. Last but not least, the electric double-layer capacitor were invented. In 1957, H. Becker developed a low-voltage electrolytic capacitor with porous carbon electrodes. He believed that the energy was stored as a charge in the carbon pores used in his capacitor as in the pores of the etched foils of electrolytic capacitors. Because the double-layer mechanism was not known by him at the time, he wrote in the patent, "It is not known exactly what is taking place in the component if it is used for energy storage, but it leads to an extremely high capacity." See supercapacitor #history.